Hello students, welcome to the video. In this video, I am going to discuss the basics of matrices, of the chapter matrices, and it is a much more important chapter for the second year HS second year classes. And in this video, I will discuss the definitions of matrices, different types of matrices, and in the subsequent videos, I will try to finish the theory part of the chapter matrices, and then we will discuss some problems based on the board exam, and then we will discuss the problems which are asked generally in the JEE main and advanced exam. And so let's get into the video with the theories and definitions of the chapter matrix. Okay, so let us begin the chapter. This is the definition of matrix. What is a matrix actually? So here I have written that a set of m by n quantities arranged in a form of a two-dimensional array having m rows and n columns enclosed by the square brackets or by the round brackets is called a matrix of order m by n. We should read this as m by n. Okay, the matrices are generally denoted by the capital letters of the English alphabet A, B, C, and so on, and the symbol Aij, this one Aij, this is used to denote the element of a matrix. Element mean the entries of a matrix. Okay, so where this Aij actually it is the address of the element we have we are to write inside a matrix, and that will be in the I number row and j number column. I will discuss thoroughly what is a row and what is a column in the next part of this video. You see, if A is a matrix of order m by n, then A can be represented by this one. It is the compact form, it is the short form to write a matrix, any matrix. Okay, you see, first of all, a set of m into n quantities mean you have say 3 into 4, that is 12 number of numbers or 12 quantities you have, and if you want to arrange them 12 quantities in some rows or columns, two-dimensional array mean you can use only row and column. You can write in the paper actually, that is two-dimensional. Okay, so having m number of rows and n number of columns, and those numbers or those quantities after writing in m rows and n columns, for example say 12 elements are there or 12 numbers are there, then you can arrange in 4 rows and 3 columns, because 4 into 3 is equal to 12, or you can arrange in 6 rows and 2 columns, or 2 rows and 6 columns, and so on. So after writing the elements in a two-dimensional array and then enclosed all those elements within this bracket or this bracket, any bracket can be used, and that is called a matrix. After writing the matrix in a two-dimensional array and then enclose them either in this bracket or in this bracket will be a matrix of the order m by n, and where this m will represent the number of row of the matrix and n will represent the number of columns of the matrix. Okay, so to represent a matrix, generally we use the capital letters of the English alphabets like A, B, C, D, etc. Okay, so the elements, also the elements mean entries of the matrix, that is the objects or quantities provided to you. So those elements is generally denoted by Aij. Here this I and j actually, this I and j, it is the row number and column number. I is representing the row number and j is representing the column number in which the element is situated. Okay, so and that types of matrix, you see, the types of matrix having the elements Aij can be write in a compact form. A is equal to Aij m by n, and here this m is the total number of row in the matrix and n is the total number of column in the matrix. So therefore therefore this I mean in which row the element is situated. So I will begin from 1 because row number 1, row number 2, row number 3 and up to the number of row may be equal to m. So I varies from 1 up to m, and j varies from again column number 1, column number 2, column number 3 up to column number n, because maximum number of column in the matrix you have taken here is n. So j varies from 1 up to n. Let me expand this matrix by writing the expanded view of this matrix. You see that one. You see this, the matrix A equal to Aij, this is an m by n matrix, can be expressed in the form expanded form. Mean I will actually trying to find the matrix in expanded view in bigger format. You see that one. This is the matrix. A is the matrix, and this element, you see these lines, horizontal lines, these are called the rows of a matrix. Row, this is row number 1, this is row number 2, this is row number 3 and so on. This is row number m. And in the similar way, these vertical lines, these are called the columns of a matrix. And that means this is column number 1, this is column number 2, this is column number 3 and so on. This is column number n. And here the first letter written in the suffix of Aij, this first letter is the number of row and the second letter is the number of column. As well, in the element part of the matrix, this is Aij are called the element of a matrix, and here also this I, that is the first letter of the suffix of A, is representing the row number, and the second letter J is representing the column number in which the element is situated. That means for that for this element, it is in which row. First of all, you see in which row it is. In the, this is first row, this is second row, so it is in the second row, therefore it is A2. Then in which column? It is in first, second, third column, so therefore it is 3. So A23 is the address of this element. Okay, similarly this element you see in which row? Second row, but column number is n number column, so it is A2n. I think you understood this. And you see the matrix Aij, this is the compact view of the matrix and this is the expanded view of the matrix. So if you want to write the first row of the matrix, then this suffix of first suffix, that is Aij, that is the value of I for all those elements in this row will be 1, because it is in the first row, therefore it is 1, it is also 1, 1 and so on, it is also 1. But it will change the column numbers. 1 1 means first column, then 1 2, this is first row, second column, then 1 3 first row, then third column and so on, first row and nth column. Similarly second row, this 2 2 2, that is second row, and 1 2 3 for the first, second, third rows columns respectively. So this is the expanded view of the matrix Aij m by n. Okay, so I already told you that these are these numbers written in the first row. This is these numbers, these numbers, these number. Actually the lines, horizontal lines are called the rows and the vertical lines are called the columns of a matrix. So I have written here, you see that the horizontal lines are called the rows and the vertical lines are called the columns of the matrix. Okay, so we go to the next section. Now we are going to discuss about types of matrix. What are the different types of matrix? And we are going to discuss that one. The first one, you see, rectangular matrix. Rectangular matrix means the shape of the matrix is in the shape of a rectangle. So it is a very simple concept that the rectangular shape means the row number and the column number must not be equal. Either row is more than column, then it can be seen like a rectangle, or column is more than row, then it is also will be in the form of a rectangle. You see the definition first. square matrix, a matrix of order m by n, whatever be the order of the matrix you are taking, that is not matter. So a matrix m by n is called a rectangular matrix if the row number and the column numbers are not equal. If they are unequal, then it is in the shape of a rectangle, and so it is known as a rectangular matrix. So let me take one example here. For example, A is equal to, you see, this is the matrix written, 1 2 3 is the first row, 5 2 1 is the second row, and you see here number of row is 1 2 is 2, and number of columns 1 2 3. So there are 3 columns, 2 rows, that is m and n are unequal, so it is seen in a shape of a rectangle, therefore it is a rectangular matrix. Again, in the similar manner, here the number of rows 1 2 3 number of rows are there, and 1 2 number of columns are there, so rows and columns are not equal here also, and therefore this is also in the shape of a rectangle, and these are actually rectangular matrices. Okay, so we come to the next part. The next one is square matrix. Square matrix means this time the matrix shape of the matrix is square form, is like a square. That means by a simple concept, you can now say that the row number and column number, if these two are equal, then the matrix is a square matrix. So first you write the definition of the matrix like this: a matrix of matrix A of the order m by n is called a square matrix if m equal to n. That is, if the number of row and the number of column of a matrix are equal, then it will be in the form of a square, and so it is known as a square matrix. So let me take one example here. So for example, A is equal to, this is the matrix, is a square matrix. It is very simple, square matrix, because it has 3 rows and 3 columns. So m is equal to n, and this is a square matrix of order 3 by 3, or simply you can say it is of order 3. In case of square, you can say just it is of order 3. So it will determine, or it will represent a 3 by 3 square matrix. Okay, so next come to the number 3 definition. The number 3 definition is row and column matrix. Name is the introduction of the matrix, row matrix. That means this time in a matrix there is only one row, then it is called a row matrix. And if in a matrix there is only one column, then it is called a column matrix. Let me define the row and column matrix first. So a matrix is said to be a row matrix if it has only one row, and it is said to be a column matrix if it has only one column. So if you write the example of a row and column matrix, it will be better understanding for you. You see, for example, the matrix A is equal to, this is the matrix 3 minus 2 1. This is a matrix of order what? Order, the row number is 1, only one row, and column number, this is 1 2 3. So its size is, or its order is 1 by 3, 1 by 3. So having one row, it is a row matrix. And this matrix, you see this matrix, it is row is 1, this is 2 number row, this is 3 number row. So row number is 3, but column number is only one column is there. So therefore this is a column matrix. Okay, and its size, or its order is equal to, number of row is 3 and number of column is 1. So it is 3 by 1. You got my point? 3 by 1. That means it is 3 by mean you have to write like this, by 1, not 2, 3 by 1. Okay, this is 3 by 1. Simple, 3 by 1 matrix. And this is actually of what size? It is 1 by 3 matrix. It is having only one row and it has only one column. Is that clear? Okay, come to the next part of the chapter. Number 4 definition, null matrix. Null matrix means this time the matrix having all the elements 0. Null matrix means 0 matrix. Null matrix is also known as a 0 matrix. that you see the definition first. So if all the entries or all the elements of a matrix is 0, this time the order of the matrix, it is not necessary to be a square matrix or to be a row matrix or to be a column matrix. That is not matter. Mean the order of the matrix may be anything, whatever be the order of the matrix is taking you are taking, but the elements, the entries of the matrix all equal to 0. In that case it is called a null matrix or a zero matrix. Is that clear? You see, all the elements of a matrix is 0, then it is said to be a null matrix or a zero matrix. So let me write one example. Also you see, zero matrix is written by the letter O actually. You may also say 0, but that 0 should be written in bold format, because this 0 or this O you may consider as O or 0 is actually not the number 0. It is a matrix 0. Matrix and a number, they are different thing. Matrix, it is holding some numbers or holding some elements, holding some objects, and a number mean it is absolutely 1 2 3 4 like that, or a real number or a complex number, anything. Okay, so null matrix mean, to represent null matrix we use 0, or 0 mean bold 0, or the letter O, bold O. You should write that like this. For example, this is a zero matrix because all the elements, all the entries of this matrix are 0, and here also it is a 2 by 2 matrix, and this is a 3 by 2 matrix. Both are zero matrix or null matrix. The null matrix is generally denoted by this letter. Already I am telling you that one. This is bold 0, not a simple 0 or not a simple O, bold O. This O is equal to this one actually, or this O is equal to this one. Okay, so this is known as null matrix. Let me go to the next part, that is number 5, submatrix. The concept is submatrix mean matrix within matrix. As like a subset, you know that subset mean sum of elements of a set taken in another set, then this set is a subset of that set. Similarly, submatrix mean within matrix you have a matrix, or you can obtain a matrix. So from a given matrix, whatever be the order of the matrix is given, from a given matrix, if you eliminate some rows or some columns or both, the new matrix obtained by eliminating some rows or some columns or both is called a submatrix of the original matrix. So first you write the definition of the submatrix like this. A matrix obtained by suppressing means eliminating, avoiding certain rows or columns or both. This is certain rows means some number of rows or some number of columns or both of a given matrix A is called a submatrix of A. So let me take one example here. For example, A is a matrix. This is a 3 by 3 matrix. You see 3 rows and 3 columns are there, and this 4 1 2 3 mean 4 1 2 3. This new matrix is obtained by eliminating this row and this column. So this is the submatrix by eliminating the third row and third column. If you eliminate say second row, only second row, so the new matrix will be what? The new matrix will be like this one, second row. After eliminating this second row, the new matrix will be 4, then 1, then 0, then 1, then 5, and then 2. This will be the new matrix after eliminating the second row. Similarly, you may also eliminate the first column. In that case, what is your matrix? In that case, the submatrix will be 1, then 3, then 5, and then here it will be 0, then 1, then 2. Is that clear? So this is the submatrix, definition of submatrix. Submatrix means matrix within matrix. Okay, matrix within matrix. Okay, so now we come to the next part of the chapter. Next part mean the definition number 6. You see the definition. So number 6 is diagonal matrix. What is a diagonal matrix? So before defining the diagonal matrix, first you have to know which elements are known diagonal elements. Before defining diagonal matrix, you are to know diagonal elements. So first of all, let me define diagonal elements of a matrix. Which elements are called diagonal elements? I am going to write that one. You see that one. So let A is equal to Aij n by n be a square matrix. This is important. This is important. In case of diagonal matrix, first of all the matrix should be a square matrix. Here you also see this is n by n, mean the number of row and number of columns of the matrix are equal, mean it is a square matrix. So to get a diagonal matrix, first condition is that the matrix should be a square matrix. So I am taking here a square matrix A. Then those elements in this matrix, if you write this matrix in expanded view, already you know how to write the complete matrix in the form of expanded form, you know that one. So after writing in expanded form of a square matrix, whatever be the order you are taking, but it should be a square matrix, then those elements for which I equal to j, that is the elements of which the row number and the column number are equal, that is those elements mean A11, A22, A33 and so on up to ANN. These elements are called the diagonal elements of a matrix. Okay, so you see the line through the diagonal elements, this line is known as the leading diagonal, or it is also known as principal diagonal. I have written here, this is called the principal diagonal, or it may also be called as a leading diagonal. Okay, so you see then the definition of diagonal matrix. I think it is clear which elements are diagonal elements. If you have the matrix, square matrix, for which I equal to j, that is row number equal to column number elements, that is A11, A22, A33, you see in the definition A11, A22, A33, that elements are the diagonal elements. Okay, so we write this one. The square matrix A equal to Aij n by n is called a diagonal matrix if all the elements except the leading diagonal mean element of the, except the diagonal elements, other elements are 0. Just the diagonal elements, they except that one, all elements are 0 in a matrix, then it is called a diagonal matrix. Okay, so you see that one. That is Aij is equal to 0 for all I not equal to j. I not equal to j mean 1 2 element, 1 3 element, 1 4 element, 2 1 element, 2 3 element and so on, where I and j are unequal. Those elements must be 0 in a diagonal matrix. So let me take one example. You see the example, A is equal to, this is the matrix, it is a square matrix, you see, because the row number 1 2 3, there are 3 rows, and 1 2 3, there are 3 columns, so it is a square matrix of order 3, and it is a diagonal matrix because these elements first row first column, that is A11, this element second row second column, so it is A22, this element third row third column mean A33, so A11, A22, A33, these are, except these elements, the other elements, all of these elements, this one, or this one, all are 0. And since it is a square matrix of order 3, so it is a diagonal matrix of order 3. Is that clear? So this diagonal matrix can also be written in short form like this one, Dig of 3 4 2. So if you write Dig of 3 4 2, then it is actually this one. So let me take another example of this type, that is, so diagonal of 2 3 1 4, so it is 2 3 1 4, and the other elements are 0. There may be 0 elements also, so this 3 may be 0. Okay, then 2 0 1 4, that question may arise in your mind. So this 3 can also be 0, this 4 can also be 0, that is, then in that case 2 0 1 0, so 2 0 1 0, that will be also a diagonal, mean that elements 2 0 1 0 will lie in the diagonal, and other element except these diagonal elements, it is obviously 0 for any diagonal matrix. Okay, so let me go through the video again. You see, number 7, scalar matrix. Scalar matrix mean, again, to get a scalar matrix, first of all this should be a diagonal matrix. Okay, and already we know what is a diagonal matrix. So in this case, mean in the case of scalar matrix, the matrix should be a diagonal matrix as well. This matrix in the diagonal elements, these are equal, all equal. You see the previous example, the diagonal elements are not equal. They may be different. If they are different, then it is a simple diagonal matrix. But if the diagonal elements are same, equal, that is, if it is 2 2 2 or 3 3 3 or k k k r r r, so in that way, if the diagonal elements are equal in value or equal, then it is called a scalar matrix. So let me define scalar matrix like this. A diagonal matrix is said to be a scalar matrix if all the elements of the diagonal are equal. Okay, so let me take one example, simple example. So for example, the matrix A is equal to, you see here, this is a 3 by 3 square matrix, and this is the diagonal, these are the diagonal elements. So all are equal, k k k, so it is a scalar matrix of order 3. Is that clear? Okay, so come to the next one. Number 8, unit matrix, and this is a very important matrix. Unit matrix is a very important matrix. It will be used further in the example we are going to done in the next subsequent classes. So unit matrix, and it is also known as identity matrix. So this time, to get a unit matrix, first of all it should be a scalar matrix. Okay, so first it should be a scalar matrix. You see the sequence. What is the sequence? First we obtain the diagonal matrix. No, first we obtain square matrix. Square matrix can be a diagonal matrix if the elements other than the diagonal are 0. And after that we have discussed about the scalar matrix. In that case, the diagonal elements are equal, other than those elements or all are 0. That is called a scalar matrix. And here, unit matrix or identity matrix, in this case the diagonal elements are equal, obviously equal, as well they must be equal to 1. If the diagonal elements are equal to 1, that means equal as well as 1, in that case it is called a unit matrix or it is called a identity matrix. So let me define that one. You write this note in your copy. So a scalar matrix is said to be a unit matrix or a identity matrix if all the diagonal elements are 1. And there is a special symbol to write a unit matrix or identity matrix. It is denoted by the letter I, capital letter I, and we write the order of the matrix as the suffix of I, as like this. You see, for example, that is Aij is equal to, so first we complete the definition. Aij mean the elements. Aij are the elements. This Aij 0 for which, where I is not equal to j, that is A21, A22, not 22, A21, A23, A24, A31, A32, A34, those elements where the number of row and number of columns are not equal, they are 0. And for I equal to j mean the diagonal elements. I equal to j mean the diagonal elements, they are equal to 1. So this definition is written in mathematical form like this. Okay, so this is the definition of identity matrix or a unit matrix. Okay, so you write that one. After that, you see here the identity matrix is of order n is denoted by in. I already told you that identity matrix is denoted by the letter I, and the order of the matrix, this is the order mean the square matrix of order n by n. Simply you can say order n, and that is written in the suffix of I. So in mean it is a identity matrix of order n. So let me write, say I3. I3 mean it is of the form, therefore I3 will be equal to 1 0 0 0 1 0 0 0 1, mean 3 by 3 matrix is identity matrix of order 3. I think it is clear to you. Okay, so come to the next one, number 9. Triangular matrix. Triangular matrix mean in this case inside a matrix a triangle shape will form, that is called a triangular matrix. So there are two kinds of triangular matrix. One is called an upper triangular matrix and other is called a lower triangular matrix. So let me define upper triangular matrix. So upper triangular matrix mean this time upper part from the diagonal elements. You already know the diagonal elements. From the diagonal elements, the upper half of the matrix is non-zero and lower half of the matrix is 0, as like this. So a square matrix A is equal to Aij is said to be an upper triangular matrix if Aij is equal to 0 for I greater than j. For I greater than j mean the elements which below the diagonal. I greater than j, that is row number is more than column number. They are situated below the principal diagonal. You got my point? You see here the example is this A equal to this one. Very simple, it is a square matrix because upper triangular matrix, before upper triangular matrix it should be a square matrix first. Okay, so this is a square matrix. Okay, so this is the principal diagonal and from the principal diagonal the lower element, this is actually A21, this is A231, this is A32. So I unequal I is greater than j. For these elements I is greater than j, this one. So I is greater than j, then Aij equal to 0 and the elements above the diagonal are non-zero. Actually that is not compulsory, are non-zero. This 3 element may be 0, this 9 element may be 0, but in the upper part of this diagonal the elements should be non-zero, at least 1 or 2 elements should be non-zero above the diagonal is a upper triangular matrix. It is of the form a triangle. You see here, this is upper part, that is it is form a upper triangular matrix. You got my point? You see this one, this is actually it is form of a triangle, so it is called an upper triangular matrix. And lower triangular mean this time these elements are non-zero, these elements are non-zero and these are 0. Okay, you see here first, let me erase this. Okay, so you go to the next one. So lower triangular matrix, lower triangular, this is just opposite to the upper triangular matrix. In lower triangular matrix you must have the elements just above the diagonal are 0. That means those elements for which I is less than j are 0. Let me first define lower triangular matrix. So a square matrix A is equal to Aij n by n is said to be a lower triangular matrix if Aij is equal to 0, for which, for those elements where number of row is less than number of column, that is the upper part of the principal diagonal. You see the example first. So for example, A is equal to, you see this matrix, this is the principal diagonal and above the principal diagonal, that is these elements are 0, is a lower triangular matrix. It is again of the form of a triangle. You see here, this is form of a triangle, so it is called a lower triangular matrix. I think it is clear to you. So next we see the so number 10 is equal matrices. So when two matrices can be equal, the first condition to get equal matrices is that the size of the matrix, size means the order, the orders of the matrices must be equal. That is the first condition to get equal matrices. And the second condition is the corresponding place elements are also equal. So let me define first the equal matrix. Two matrices A and B are said to be equal if they are of the same order and their corresponding entries are equal. That means, you take one example to understand this equal matrices. So let me take a matrix A is equal to this one and a matrix B equal to this one. These two matrices are of same size. You see, this is 2 by 3 size, this is also 2 by 3 size, because 2 rows and 3 columns. Here also 2 rows and 3 columns. Okay, so these two matrices are equal matrix if this element is equal to this element, mean x equal to a, y equal to b, z equal to c, and so on. I have written here x equal to a, y equal to b, z equal to c, p equal to l, q equal to m, and r equal to m. So this, if these two conditions are satisfied, then we say that the matrix A and the matrix B are equal matrix. So with this we finish this class, and in the next class I am coming with the operation of matrices, mean how to add two matrices or how to subtract two matrices, and one important topic, how to multiply two matrices. And you should always keep in mind, in matrix there is no division of matrices. These three fundamental conditions are discussed in matrix, that is sum, difference, and product. No division operation can be hold or can be used in matrix. Okay, so we will discuss these three fundamental operations of matrix in the next class. As well, we will discuss the transpose of matrix, the inverse of matrix, and scalar multiplication, and some important topics. I am coming with these topics in the next video. Okay, so after that we will do some problems of the board level questions, and then we will discuss some problems of JEE main and JEE advanced level questions. As well, we will touch or we will discuss every corners of the chapter matrix, so that a single question cannot be a single question is so that a single question is unleft in your JEE advanced or JEE main exam. Okay, so till then, goodbye and thank you very much.